All right, let's finish 2.3 up, quadratic functions. So above, we learned how to complete the square, which will use that process to help us graph quadratic functions. Okay, so given a quadratic function, we know the standard form is f of x equals ax squared plus bx plus c. Right, there's a standard form. And if we complete the square, we can put it into vertex form, which is right there. Okay, so we know we can do that already. Now we'll actually make use of the vertex form. But before we begin, let's look at the graph of a quadratic function. Being quadratic means you are to the power of 2. The highest power is 2. It is a second-degree polynomial. And some characteristics about quadratic functions. Well, the graph of quadratic functions is that the graph of a quadratic function is called a parabola. It's called a parabola. So the graph of any quadratic function is called a parabola. And some characteristics about a parabola is that if the leading coefficient a of your quadratic function is positive, so if the leading coefficient is positive, your parabola will open up. Your parabola opens up. Okay, and if your parabola opens up, there are some other characteristics here. So for parabolas, your main point of the parabola is called the vertex. The main point of the parabola is called the vertex. And the vertex is always given by the coordinates hk. Okay, and then a next part of the parabola is you will always have one y-intercept. You will always cross the y-axis. So you will always have one y-intercept. Okay, and then as it opens up, we see that it crosses the x-axis. Okay, well, for a parabola, you could possibly have 2 x-intercepts, 1 x-intercept, or you can even have no x-intercepts. So we can cross the x-axis, we can cross it twice, we can cross it once, or we may not even cross it at all. So for a parabola, for a quadratic function, once again, you could have 2 x-intercepts, 1 x-intercept, or no x-intercept. Okay, and then the last piece of our parabola is that we have something called the Axis of Symmetry. It cuts straight through the middle of your parabola. And the key word here is symmetry, which means it reflects across the line. Meaning if I have a point here on the parabola, I can reflect it across the axis of symmetry to get another point there. That's all it says. So if we need help finding points or plotting points, the axis of symmetry becomes our best friend. Okay, there you go. So those are characteristics of a parabola that opens up. The one to the right is a parabola that opens down. It has the same exact characteristics. The only thing different is that the leading coefficient is now negative, less than 0. And if the leading coefficient of a quadratic function, and when we're saying a, if you're wondering what a is, remember quadratic functions are always given as ax squared plus bx plus c. And this a value, if positive, will open up. This a value, if negative, will open down. And if we open down, well, once again, we have our vertex, which is given by hk. We have the 1 y-intercept. We have the 2 x-intercepts, or maybe 1 x-intercept, or maybe no x-intercepts. And we have the axis of symmetry. So if a parabola opens up or parabola opens down, they have the same characteristics. The only difference is one opens up, one opens down. Okay, excellent. And when I say you may have one X-intercept or no X-intercept, here's what it would look like. A graph with one X-intercept could look something like this. You come down, you touch the X-axis, and you go. That's it. You only have 1 point on the X-axis, so one X-intercept. A parabola with no X-intercepts could look like this. You don't even touch the X-axis. Therefore, you would have no X-intercepts. And of course, there could be other examples of this as well. I could have a parabola that opens down. I could have a parabola that opens down this way. So these are other examples. Okay. Let's keep going. Okay. Now some pieces, putting labels on what we have. We'll start with the vertex form. And in vertex form, well, if you're in vertex form, you can automatically find the vertex. The vertex is given by H, K. H and K, all right? And then if you have the values HK, you can then find your axis of symmetry, your line of symmetry. And this one's pretty easy. If you know the H value from your vertex, you know the value from for your line of symmetry. Simple as that. That was easy, right? Yeah. Okay. Now let's say we're given standard form and we don't want to complete the square to find the vertex. That's totally fine. To find the vertex in standard form, well, now we have to use a formula. The formula to find the vertex in standard form is H equals negative B over 2A and K equals F of H. So what this means is that once you find H, in order to find K, you're going to have to take this H value, plug it in for X, and the output would be K. So that's what you'll do there. You'll use the formula. Sometimes this is faster, especially for applications. Okay. And just like before, if you know the H value from your vertex, you know the value for your axis of symmetry. Look at this. H is negative B over 2A. Here your axis of symmetry is X equals negative B over 2A. And negative B over 2A is just H. So not much different there. So if you're in vertex form, you can automatically find the vertex. If you're in standard form, we use a formula to find the vertex. Okay. And now, go over some basic concepts. We know to find a Y-intercept, you let X equal 0. Hang on. There we go. To find a Y-intercept, you let X equal 0. That's nothing new. We've done that for linear equations. We did that for the shaded graphs. To find an X-intercept, you let Y equal 0. Again, nothing new. You let Y equal 0 and you solve for X. We also did that for linear equations, the inequalities, and the shaded graphs. Okay, but let's say this time X wasn't so easily solvable. Then there's other methods to find X. Factor it, use a quadratic formula, or complete the square. So now we have all these methods to solve for an X-intercept. Okay. Now something new. A quadratic function has a maximum at the vertex if the leading coefficient is negative. A quadratic function has a max at the vertex if A is negative, which means, let's go back up here. So what we're saying is that if A is negative, meaning if A is less than 0, our parabola opens down and it will have a high point, which is the vertex, which will also be considered a maximum. So we'll have a maximum, and the maximum occurs at the k value. So max at k. Okay. And then the next definition says you will have a minimum if the leading coefficient is positive. You'll have a minimum if the leading coefficient is positive, which means your parabola opens up, and if it opens up, it creates a low point, the lowest point, which is the vertex, which will be considered a minimum. And guess what? The minimum also happens at k. All right. So if your parabola opens up, you have a minimum. If your parabola opens down, you have a maximum. A low point and a high point. Okay. Range. If you have a maximum, the range is all your y values to the maximum. So let's go look at that. So for this one, the range. And the reason we start with this graph is because it has a maximum. So to find the range of this quadratic function, this quadratic graph who opens down, well, the first thing we must look at is where are these tails headed? These tails both are headed towards negative infinity. And whenever you state domain and range, you always start with the lowest possible number. And that lowest possible number is negative infinity. And then you will come up the graph until you reach the k value of your vertex. So remember that your vertex is also always given an hk. K is the y value of the vertex. And for range, we only state y values. So your range will go from negative infinity and stop at k. Or my math lab may put it as, let's see, if it's negative infinity to k, then you're going to have that k must be less than or equal to negative, actually not less than, greater than, right? Whoops, sorry, my bad. Reverse. We're going to say k has to be greater than or equal to negative infinity. Okay. And then the next one says, whoops. If your parabola opens up, then your range well, let's look. Our graph starts down here at k and heads up towards where? Infinity. So to state the range for a parabola that opens up, we would say start at the smallest y value, bracket k, and now state the largest y value, and these are headed towards infinity. So the range for a parabola that opens up would go from k to infinity. That's it. And this means that you could start at k, and you would have to be, k is, let's see, bracket k to infinity. This means that k would have to be less than or equal than infinity. Okay. All right. So there's our range. And one thing we didn't cover was the domain. All right. Well, quadratic function is a polynomial. And we have stated before that the domain for all polynomials is negative infinity to infinity. So no matter what parabola you draw, the domain will always be negative infinity to infinity. All right, and then same thing here. Okay, and there it is. All right. So now we know all the characteristics of a parabola. Now we can go ahead and start graphing. So find the vertex form, the vertex, the intercepts, the max or min, the range, and graph it. Woo! Okay. So this means that to find the vertex, we must put it into vertex form. So in order to put it in a vertex form, we must complete the square on a function. And it's a good thing we know how to do that already, right? Yeah. All right. So that's what we're going to start. Let's see. There we go. So we'll call this A. Vertex form. So you get f of x equals x squared minus 4x plus 3. And we're going to complete the square on it, meaning the leading coefficient has to be 1. And it is, which means that this function is in the perfect form already. So this means that all I have to do is group these two terms together and complete the square. So we're going to say CTS. And when we complete the square, we take half of the middle term's coefficient. So -4/2 squared. Simplify, you get -2 squared equal to 4. And then the next step is take that number and add it and subtract it on the same line. X squared minus 4x plus 4 minus 4 plus 3. And then group these two terms together and factor. Which means you'll get f of x equals x minus a number times x minus a number. And remember the trick, what number goes in there? It's the number that you squared, which means we're going to put in -2. So -2, -2. And then simplify these last two, right? I'll just say combine. And that's -4 plus 3, which gives us -1. Almost there. F of x equals x minus 2 squared minus 1. Here is vertex form. Which means next, B, we just want the vertex. The vertex is given as HK. And looking at vertex form, remember vertex form is a times x minus h squared plus k. So whenever we state, so listen carefully, whenever we state the h value, we always say the opposite. So look at our vertex form. Our h value says -2. But since this is a horizontal transformation, which you guys probably will never know, since it's a horizontal transformation, it means you shift everything to the right 2 units. You move everything a positive way 2 units, which means instead of stating -2, we always say the opposite. So when I put my vertex coordinates down, I'm actually going to write +2. And then for my k value, you state it as it is. My k value is always the same, so k is -1. My coordinate here is 2, -1. All right. And the reason we always say the opposite for h is because it's called a horizontal transformation. And you always do opposite what the sign says. If it's -2, you shift to the right 2 positive units. If it was +2, you would shift to the left negative units. So horizontal transformations always are opposite. So whatever number you see there, just say the opposite. If it's -2, you put 2. If it's +2, you put -2. Okay. Which means here is the vertex. All right. Next is the intercepts, X and Y intercepts. Let's go for the X-intercept. When you look for the X-intercept, we let y equal 0. In this case, we're in function notation, so we have to say let f of x equal 0. Okay. This means take our vertex form x minus 2 squared minus 1 and set it equal to 0, because that's what we're doing. We take that whole function and we set it equal to 0. Now our job is to solve for x. So I'm going to add the 1 over. And then I need to solve for x. So I will introduce the square root method, right? Because that's how we get rid of the square. So I'll say square root. And you'll get x minus 2 equal to, and remember, whenever we're solving for a variable and we square root both sides, we always have 2 answers. Plus or minus 1. Then add the 2 over, and x equals plus or minus 1 plus 2. And now you have your 2 routes. We have to do the plus route and the minus route. This room, I guess I'm doing good on room. All right. So you'll have x equals +1 plus 2, and x equals -1 plus 2. Here you'll get 3, and here you'll get 1. Now, since they are x-intercepts, change them into coordinates. So this is going to be 3, 0, 1, 0. All right. So there's the x-intercepts. Now, find your y-intercept. And to find the y-intercept, you let x equal 0. Okay? We'll just keep rolling with the vertex form. Plug in 0 for x. You'll have f of 0 equal to 0 minus 2 squared minus 1, which will give me negative 2 squared minus 1, which will give me 4 minus 1, which gives us 3. Now translate that into a coordinate. 0, 3. Okay, x-intercept, y-intercept is done. Next it says find a max or min. Well, you can do this by graphing. I mean, we're going to graph it anyways, but you can also do this just by looking at the function. So look at the leading coefficient. Remember that our leading coefficient is 1. Is 1 positive or negative? 1 is positive. And if 1 is positive, if the leading coefficient is positive, our graph will open up, creating a minimum. So that minimum will happen at the k value of the vertex. So it's good that we actually know the k value of the vertex. K is -1. So where could I write that? I'll do that over here. We'll say add A, B, C, and this would be D, right? Max or min. And since A is greater than 0, meaning A is positive because A is 1, we have a minimum. Minimum at y equals, and what was our k value? -1. Or it could even say k equals -1, but as long as we know where that minimum is at. Okay. And now let's just prove it by graphing. So let's see what our coordinates are. Okay. So first off, my vertex is at 2, -1. So that's what we'll draw first. 2, -1. So 1, 2, -1. Here's my vertex. And then I look at my x-intercepts. I have x-intercepts at 3, 0, and 1, 0. So let's plot those. 1, 2, 3, 3, 0, and 1, 0. Okay, those are my x-intercepts. And the last point we have is the y-intercept, which is at 0, 3. All right, well, you only need 3 points to graph a parabola. You need the vertex, and you need a point to the left of the vertex, and you need a point to the right of the vertex. And we have all of those. So since we have all of those, go ahead and connect them. And there's my parabola. Okay, This one didn't want axis of symmetry. Okay, good. All right. All right, so now we see that our parabola opens up, which means that we do have a minimum because the graph opens up, and that minimum happens at -1, at the y value of our vertex. Okay, and then E says the range, so just put E here, the range, our range goes from, it starts, well, since our parabola opens up, our range will have to start at the smallest y value. And the smallest y value is -1. And those tails are headed towards infinity. So -1 to infinity. All right. So I think the way that my math lab wants to state it is that all your y values will be greater than or equal to -1. So we can state it as y values greater than or equal to -1, because they start at -1 and they go greater than towards infinity. So I think this is what we're looking for. Okay. And then F was to graph it. Well, we graphed it. Perfect. Okay. And that's how we graph a quadratic function. It is the graph of a parabola. And those are all the components. Okay. Again. Six. S of x equals -5x squared minus 40x minus 78. Let's do it all over again. This one looks like it's gonna be ugly. So A, vertex form. So I'll rewrite the function. S of x equals -5x squared minus 40x minus 78. We see that the leading coefficient is not 1. The leading coefficient is -5, which means we're going to have to make it 1 by factoring out the -5. I'm going to say factor -5 out. And to give us more room, I'll continue down here. So we'll start on the left. If I take that -5 out, from those two terms only, remember, only from the x terms, I'll get positive x squared plus -5 from 40 is positive 8, right? 8x minus 78. Okay, and now we look, and that leading coefficient is now 1, which means we are ready to complete the square. CTS. We take half of the middle term's coefficient, which is 8, over 2, and square it. You'll get 4 squared, which gives me 16. All right. Next, add that number and subtract it on the same line. So you'll have -5 times x squared plus 8x plus 16, and then minus 16, minus 78. Okay, and then factor. We're going to factor this part and leave that negative 16 alone. So S of X equals negative 5 times, oh yeah, bracket for neatness, X squared plus 8X plus 16. Now you know how all of these factor. So this is just going to become X plus, and what number goes inside? You guessed it. The number that we squared, which is 4. So this will be X plus 4 squared minus 16 minus 78. Now distribute the negative 5. And we'll have negative 5 times X plus 4 squared plus, what's 5 times 16? Is that 80? Yes. Plus 80 minus 78. Clean it up, and we have our vertex form. That one wasn't bad. I thought we were going to get fractions. S of X equals negative 5 times X plus 4 squared plus 2. Okay. And there's our vertex form. Now, we get our vertex. There's the H value, which is 4. So remember, we always think opposite for the X values. If it's plus 4, our H value will be negative 4. There's K. K values stay the same. 2. There's our vertex. Moving on to intercepts. X-intercept, let f of x equal 0, set the vertex form. Negative 5 times x plus 4 squared plus 2 equal to 0. And solve for x. Move that 2 over. And then we need to get x plus 4 squared by itself. So then you'll divide by negative 5. Which means we'll have x plus 4 squared equal to positive 2/5. Okay, and then square root, square root. Ooh, this is gonna get ugly. All right. So you'll have x plus 4 equal to plus or minus the square root of 2/5. Oy, how do we do that? Let's see. Okay, and I'll show you on the calculator. In case you're wondering, I'll just say second square root 2 divide 5. Easy as that. Enter. And I assume we'll just do it to 2 decimal places. So here, you'll get 0.63. All right. Then subtract the 4 over. Plus or minus 0.63 minus 4. Do the plus route, do the minus route. X equals 0.63 minus 4. And x equals 0.63, actually, sorry. Negative 0.63 minus 4. So calculator comes in handy. Negative 3.37 and negative 4.63. Convert to coordinates. Okay. And now the Y-intercept. That was definitely a process. And x equals 0. So we'll have f of 0 equals negative 5 times 0 plus 4 squared plus 2. This will give me negative 5 times 4 squared plus 2, which gives me negative 5 times 16 plus 2, and negative 5 times 16 plus 2, negative 78. Convert 0, negative 78. Okay. Let me go back to this. And let's graph. We'll do max or min, range, all out after we graph it. So let's do that. So let's look at our vertex. It's at negative 4, 2. Negative 4, 2. Okay. So negative 4, 2. So 1, 2, 3, 4. There's my vertex. My x-intercepts, we're at negative 3.37. So hang on. Negative 1, 2, 3. Negative 3, negative 4, negative 5. Okay. So at negative 3.37, I'd put it somewhere around here. And then at negative 4.63, somewhere around there. Let me get rid of those. All right. Those are the x-intercepts, right? And then our y-intercept is at -78. Oh boy. Well, it's a good thing we only need 3 points to graph this. A vertex, a point to the left of the vertex, a point to the right of the vertex. And since the leading coefficient is negative, we will open down. So just open down. And somewhere down there, you'll hit your y-intercept of -78, right? Let's just pretend. Let's say that's our y-intercept, just for pretend though. Because it should be on the y-axis, right? Or do I have room for pretend? Let me see. Let's do that. We'll say this comes down and just intersects it there. And there's my y-intercept. Why not? Okay. Okay, so the last thing it wants is max, minimum, max or min or range. So this opens down, so there will be a maximum. And since my vertex is at -4, 2, our max is at y equals 2. Our range, well, the tails go down to -infinity. So we start at -infinity. We come up, and we stop at the y value of 2. And once again, what I think my math lab is looking for is the inequality. So you would write it as all your y values have to be less than or equal to 2, meaning all your y values are headed towards -infinity. Okay, and there's the graphs. Those are done. How long was that? Probably long. Let's keep moving. Applications. Woo! All right. We found that the marketing research department for the company that manufactures and sells memory chips for microcomputers established the following price, demand, and revenue functions. P of x equals 125 minus 3x is the price demand, and R of x is x times, or revenue is x times 125 minus 3x. Where P of x is the wholesale price in dollars at which x million chips can be sold, and R of x is in millions of dollars. Both functions have the domain of 1 million chips to 25 million chips. Okay, graph the revenue function. Okay, let's graph the revenue function. Well, it's a good thing it's giving us the x values to pick. Whenever it gives us the domain, that's a good thing. It says, hey, choose numbers 1 through 25. So let's make an XY chart, and I'll show you how to use your calculator again. Okay, so revenue is given by x times 125 minus 3x. Well, why not just distribute the x? And get 125 minus 3x squared. Okay, then let's just make an XY chart. Use a different color. And pick the X values it's telling us. 1. And if we're going to go to 25, let's go by 5s. 5, 10, 15, 20, 25. Okay, calculator time. I've shown you this before, so let's do it again. I'm going to go, this is just on the scientific calculator. So hit table, and then type in the function we have. 125x minus 3x squared. 125x minus 3x squared. Hit enter, enter, enter. If you left it on ask x from last time, then it should still be on it. Hit enter. And now if there's values there, just delete or overwrite them. And now let's type in our values. Let me zoom in over here so I can fit that. There we go. All right, so 1 gives me 122. Perfect. 5, 550. 10, 950. 15, 1200. 20, 1300, and 25, 1250. Okay, there you go. Easy as that. Now let's go to the graph. Label appropriately. Let me do the x-axis really fast. 1, 5, 10, 15, 20, 25. Okay, let's look at our y values. 100, 550, 950, 1200, 1300, 250. We can go by, I think we go by 200s. Yeah, let's go by 200. So 200, 400, 600, 800, 1,000, 1,200, and 1,400. Yeah, the highest we go is 1,300. All right, and now let's plot. So at 1, I'm at 122. So that'd probably be somewhere around there. 5, we're at 550. So somewhere close to 600. 10, I'm at 950. So somewhere close to 1,000. 15, I'm at 1,200. Hey, right on the money. 20, 1,300, a little bit above the last one. Or would that be right in the middle? I think that'd be right in the middle, right? And then 25, 1,250, back down. Okay. And here's what our graph looks like. Okay, perfect. See, a little calculator work to help us out. All right, find the output that would produce the maximum revenue. Okay, so when you are asked this question, all it wants is the H value from the vertex. Find the output that would produce the maximum revenue. All this is asking is say, hey, find the H value from the vertex. So R of x is a quadratic function. 125x minus 3x squared. So I'll rewrite it down here. Is a quadratic function. Oops, don't forget the x. 125. Let's do that over. There you go. Is a quadratic function. And what we know that we can do in quadratic functions is find the vertex by completing the square. But what's great about these applications is we can use the optional method too of finding the vertex. So remember in option 2, if our function is in standard form, which it is, to find the vertex, we just have to use this formula. H equals negative b over 2a, and k equals f of h. So this question, like I said, wants to know what is the output that will produce the maximum revenue. H is going to be considered the output because in terms of the problem, we are outputting chips, computer chips. So H is the output, which means all we have to know to find H is the value of B and the value of A, which means you have to see this as a quadratic function. In a quadratic function, you know the values of A and B are the coefficients of x squared and x. So if you want to rewrite the revenue function in highest power to lowest, we can rewrite it as R of x equals negative 3x squared plus 125x, where you see that the value of A is negative 3, and the value of B is 125. And if we know A and B, we can find H, which means that H equals negative B over 2A, which will give me negative parentheses. Never forget your parentheses. Negative 125 over 2 times the value of A, which is negative 3, which will give me negative 125 over negative 6, which gives me, well, positive 125 over 6. And it says leave answer as a fraction. So this does become 20.83333 repeating, but it says leave as a fraction or an integer. Well, we can't leave it as an integer because an integer is a whole number. And this isn't telling us to round. So we're going to leave our answer as 125 over 6. So what this means is that since this is the output, we also have to interpret what it means. We have to say if x equals 125 over 6 million chips, this will increase the maximum revenue. or this will produce the maximum revenue. Okay. So to go over it again, if you see the words, find the output that will produce the maximum revenue, all that means is find H. That's all that means. Find H from the vertex. Okay. Well, what's great about this is the next question and this question go hand in hand. This now says, what is the maximum revenue? Well, this is looking for the K value of the vertex. Because if we make 125 over 6 million chips and then plug it into the revenue function, that'll give us the vertex. That'll give us the amount of maximum revenue. Okay, so what is the maximum revenue? All this means is find K. And using the answer from above, K is going to be R of H. Do we know the H value? We sure do. You're going to get R of 125 over 6. And you're going to plug this into the revenue function for X. So you'll get -3 times 125 over 6 squared plus 125 times 125 over 6. And whatever we get will be our maximum revenue to 2 decimal places. Okay. And you're probably wondering, how do I type that in the calculator? Well, just like this. -3 parentheses 125 divide 6 squared plus 125 parentheses times 125 divide 6 close parentheses. Enter. And our maximum revenue, if we sell 125 over 6 million chips, I think the reason it wants to leave it as a fraction is because it's a run-on number. Way to go, my math lab, right? So you can't have a run-on number of computer chips, can you? No. So they leave it as a fraction to be more exact. But now here, if we sell 125 over 6 million chips, we'll get $1,302.08 in maximum revenue. This is the max revenue. Okay, awesome. Also, with the fancy calculators, you don't have to type it in as 125 divide 6. You can do the fraction button. 125 over 6 squared plus 125 times fraction button. And get the same thing. It's neat. Oh, well, our money is in millions. So what I would do is because we got 1302, but they have to say that that's in millions. So you could take 1302.08, multiply it by 1,000,000. Because if we sold computer chips, I'm pretty sure $1,000 would not support our business. So 1,000,000 would give me, oh, that'd give me billions, wouldn't it? You get 1, comma, we'd be rich. Let's just say that. So if it wants that number, you just take whatever we got for max revenue and say it's in millions or put it into millions. Okay. And then D, what is the wholesale price per chip that produces the maximum revenue? Okay. So what we're going to do is take our X value of 125/6, or take our H value. H is the same as X. Let's take that H value of 125/6 and plug it into the wholesale price, which is given by the price demand function above. So we're going to use this function now and plug in 125/6. And this will give us the price we are actually selling these computer chips at. And then we'll say P of 125/6 equal to 125 minus 3 times 125/6. And calculate. And you'll get 125/2, but it wants this in dollars. So you should get that we are selling these computer chips for $62.50. This is the price per chip. Okay, there you go. Okay. One more. It's like the long one. They've all been long, right? Okay. A company that sells notebook computers has the following revenue and cost functions. X times 2,000 minus 68 is the revenue function. And C of X equals 4,000 plus 500X is the cost function. And C of X and R of X are in thousands of dollars, and X is in thousands of computers, and they both share the same domain. They must stay between 1,000 computers and 25,000 computers. Okay. Awesome. So first thing is find the profit function. And you see the formula for profit is given here. Profit is given as the revenue function minus the cost function. Well, we're given a revenue and cost function. Let's plug those in, subtract them, and we'll get the profit function. So let's do that. So you'll get is equal to R of X, which is minus C of X Notice how everything's in parentheses. We got to be proper. Now, on the first one, I'm going to distribute the X and drop the parentheses. On the second one, all I have to do is distribute the negative. And now, combine like terms, and we have the profit function. What do I have? 2,000 minus 500, so plus 1,500x minus 4,000. And there you go. That is the profit function. It's revenue minus cost. All right. So negative 60x squared plus 1,500x minus 4,000. Just making sure we're good with all our signs. We are. So let's move on to the next one. Sketch, 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 sketch. Sketch the graph of the revenue, the cost, and the profit function. Oh boy. Okay, so let's make XY charts for all three. I know. But a good thing we have a calculator, right? And they're giving us the X values to use again, 1 through 25. So first up will be revenue. So say X and R of X equals, what's revenue? Revenue is, if I distribute the X like I did up there, and again, it's giving us the values, 1 through 25. So 1, 5, 10, 15, 20, 25. Okay. But I want to do this for all three just to get it done with. So let me set everything up. Cost is 4,000 plus 500x. Same thing. 1, 25. And last is a XY chart for profit. Did I leave room? I probably didn't. It'll fit somewhere. Let me see. I'll just zoom in more here until I can't zoom anymore. What's profit? Negative 60x squared. Nope, that's not going to fit. One moment. We'll just make the XY chart up here for it. Why not? Okay, let's get started. Revenue. So, calculator time. Table, clear, type in revenue. 2000x minus 60x squared. Hit enter, 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 enter. Got 1, 5, 10. $1940, 8,500, 14,000, and then 15, 20, 25. 16,500, 16,000, 12,500. All right, not bad. Next one. Cost. Go back to table, clear out that, put in cost, 4,000 plus 500x. And 15, 20, and 25 are there already, so let's fill them in. Look at that. 15, 11,500. 20 is 14,000. 25 is 16,500. And then 1, 5, 10. 4,500, 6,500, and 9,000. Whew, one more. Profit. Let me type that in. Clear. Negative 60x squared plus 1,500x minus 4,000. There we go. And one, hey, look at that. Negative 2560. And then there's 5 down there. 2,000. 5,000. And then 15, 20, 25. 15 is 5,000 as well. 20 is 2,000. And 25 is negative 4,000. Oh, all right. Go calculator. Now let's plot. I'll make my x-axis according. So 1, 5, 10, 15, 20, 25. Let's look at all my y values. 1940 to 12,500, 4,500 to 16,500, and negative 2,005 to negative 4. So I think I'm gonna go by 2,000. That's easy. Don't even worry about negative stuff, because for our business model, we should only have positive numbers. So I'll show you how to graph it. Okay, so 2, 4, 6, 8, 10, 12, 14, 16, 18. And this is in thousands. Okay, profit was blue, so we'll start with that. One in 1940, it's a sketch, doesn't have to be perfect. One in 1940, 5 in 8,500, somewhere around there. 10 in 14,000 exactly. I like that. 15 and 16,500, somewhere around there. 20 and 16,000, right in the money, that's nice. And 12 and 12,500, somewhere right there. So here's profit. Here's revenue. And then green is cost. So 1 in 4,500, somewhere there. 5 in 6,500. Probably around there. 10 and 9,000. In the middle there. 15 and 11,500. Somewhere there. 20 and 14,000 exactly. Right there. And 25 and 1650. Probably right there. Okay. Now here is cost. Whew. All right. Next one is profit. At 1, we're negative. So let's just say that point is down here somewhere. 5, we're at 2,000 exactly. 10, we're at 5,000. 15, we're at 5,000. 20, we're back at 2,000. And 25, we're back in the negative, so somewhere down here. So here's what profit looks like. Whew. Done. The graph is done. Keep moving, keep moving. All right. C, discuss the relationship between the intersections of the graph of the revenue function and the cost function and the X-intercepts of P. Okay, cool. So, okay, I get it. All right. So if we look at this, whenever revenue and cost intersect, it is called break even. So whenever revenue meets cost, these are called break even points. Which means that at the intersection of the revenue and the cost function, at these intersection points, revenue is equal to cost. So that's what we could write here. at the intersection, revenue equals cost. This means we have broke even. This means that if revenue has met cost, this means that there is no cost and there is no revenue and there is no profit. This means that profit must be zero because we have broke even, right? We have came out of the negatives. So at the intersection, revenue is equal to cost and profit, or the x-intercept of the profit, must be zero. Because if you look at the x-intercepts of the profit function, well, if these are x-intercepts, then y must be zero. Profit must be zero. So this would be x0, and that would be x0. And the reason I put 0 is because, the reason I put 0 is because if they break even, profit is 0. The reason I put x is because we don't exactly know what those points are. Okay, good. Can we find out what those points are? We definitely could, which I think is the next one. So, find the x-intercepts of the profit function. These are also called break-even points. You see, everything we said above, because revenue is equal to cost. Okay, so find the x-intercepts of the profit function. So let's get the profit function back. P of x is negative 60x squared plus 1500x minus 4,000, right? That would profit negative 60x squared plus 1500x minus 4,000. Okay, well, to find x-intercepts, we let y equal 0. In this case, y is the function p of x. And let's see what happens when we do that. So you set p of x equal to 0, which means negative 60x plus 1500x minus 4,000 is set equal to 0, which means we have a quadratic equation. In multiple ways to solve a quadratic equation. We can factor, we can complete the square, or we go to our good old friend, the quadratic formula. And for this one, believe me, you're going to want to use the quadratic formula. So again, just remember that this is in the form of ax squared plus bx plus c. So label what a, b, and c are. This will get us started on using quadratic formula. So a is negative 60. B is 1500. C is negative 4,000. Now plug these into the quadratic formula. What is the quadratic formula? Oh, you know it, right? You've seen it before. Let's write it real fast and then I'll erase it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Breathe it in. And the reason I'm going to erase it is because I need room. Okay, but I'll leave it there for now. So quadratic formula this, and you'll get x equals negative b, which is 1500 plus or minus the square root of b squared minus 4 times a, which is negative 60, times c, which is negative 4,000. All over 2 times a. If ugly. Okay, and now I'll move up here. So goodbye, quadratic formula. And of course, I like to save time because this is probably a really long video now. So negative 1500 plus or minus, what I'm gonna do is all of the square root work. Get ready, calculator. Just the square root though, just that part. So second, square root, parentheses, just like I wrote it, 1500 squared minus 4 times negative 60 times negative 4,000. Hit enter. Oof. 1335.78. So that's what's going right here. Over, what do we have? Negative 60? No, not negative. Negative 120, right? Negative 120. Okay, let's do it. We have two routes, a plus route and a minus route. So let's do it. First one. X equals negative 1500 plus 113578 over negative 120. So what's beautiful about this is we can type this exact thing in this calculator. Watch. Fraction button. Negative 1500 plus 1135.78 over negative 120. Enter. And to 2 decimal places, I get 3.04. There's the first one. Now we have to go the minus route. X equals negative 1500 minus 1135.78 over negative 120. So I'm just going to go back and write the same thing, except I ruined it. No, I'll make it minus 1135.78. There we go. Negative 1500 minus 1135.78. Enter. To 2 decimal places, 21.96. All right. And these are the X values for your break-even points. So it says find the X-intercepts, and we have them at 3.04 and 21.96. It may make you round, so you can have 3 and 22 possibly, right? And those are the points on the profit function that weren't labeled above. So the x0 and the x0, that would be 30 and 22.0. So this means that at 3 million or 3,000, X is thousands of computers. So of course, interpret it at 3,000 computers, we break even, and at 22,000 computers, we break even. Okay. Last one. Okay. Find the value of X that produces the maximum profit, and then find the maximum profit and compare it to the maximum revenue. Oof. So this means we need to find the vertex for the profit function, and we need to find the vertex for the revenue function. And we're going to use that lovely little vertex formula. So that's all this problem says, is find the vertex and compare for the profit and the revenue. Okay. So write the profit function again. P of x is negative 60x squared plus 1500x minus 4,000. And to find the vertex, we use h equals negative b over 2a and k equals p of h, because our function here is p. Okay, so it's a good thing we know what a and b are already from the profit function. A and b were labeled above. A is negative 60, b is 1500. That's what we'll use here. So we'll say h is negative b, which is negative 1500 over 2 times negative 60. And negative 1500 over negative 120 gives me 12.5. So if we're going to have maximum profit, we need to make 12.5 thousand computers. And now wants to know what is the maximum profit. So this would be the value of x, right? Find the value of x that produces the maximum profit. So 12.5 is our x value. I'll just put that there. And then after that, it says find the maximum profit. So now we're going to take 12.5 and plug it into the profit function. That's all we have to do, which means you're finding k, right? So k is p of 12.5. And I won't write it all out. I'll go straight to the calculator because the calculator is my best friend today. So I'm going to just type it into this function right here. So watch this. Negative 60 times 12.5 squared plus 1500 times 12.5. Don't forget any zeros, minus 4,000. 5375. max profit in thousands? Yep, thousands of dollars. Max profit in thousands, just as long as you understand that. Okay, and now let's compare it to maximum revenue. That's all it wants. So which means we have to do the same thing for the revenue function. What's revenue? 2000x minus 60x squared. Which I'll rewrite so it's in its proper form. And let's find h. Oh yeah, so this is a and that's b, right? Don't forget your x's. Okay, so h is going to be negative 2000 over 2 times negative 60. I get 16.67. So knowing my math lab, this will probably want to leave it as 50 over 3. So in order to have maximum revenue, we need to make approximately 16.7 or 17,000 computers. Okay, and now take 50 over 3 and plug it into revenue. And what are my instructions on this? Find maximum profit. Nope, didn't say to round anything. So here I get K, which is going to be R of 50 over 3. Again, I'm going to save some time here. Go straight to my calculator. And take 50 over 3 and plug it into revenue. So I should get negative 60 parentheses 50 over 3 squared. So negative 60 times 50 over 3 squared plus 2000 times 50 over 3. And we get maximum revenue at 50 over 3,000 computers will be $16,660.67. In thousands. This is max revenue. Okay. Well, the difference is a lot, but remember that profit is the money we take home. Revenue is the money we make, but we also have to subtract the cost. So if you do revenue minus cost, whatever the cost is, we'll get 5375 as our revenue. But of course, this is at a different number of computers. Okay. And that is it. My goodness. Was it long? Yeah, but full of good information. Okay, that's it. That is 2.3.